In the previous video, we learned how to use normal CDF in the TI-84 calculator to compute probabilities in a normal distribution when we're given the x values. Now in this video, we're going to turn the problem around and use the inverse norm function in the TI-84 to convert from probabilities back into the x values. So we're going to use inverse norm to solve three different types of problems in the context of this simple normal distribution for SAT scores, where we're given a mean of 1,000 and a standard deviation of 200. So for our first question, we're asked what the SAT score is for a student at the 75th percentile. And it's probably wise to shade in the corresponding region so we can use estimation to check our answer. So in the calculator, we press second and then vars. This gets us to our statistical distributions. And then we go down to the inverse norm function. And we put in an area of 0.75. That's that probability to the left of the cut line. We put in a mean of 1,000. And again, our standard deviation for this distribution was 200. Note that on this calculator, we can select left to indicate we're talking about an area left of the cut line. Now on some older models of TI-84s, the calculator always assumes you're talking about an area left of the cut line. And we'll see how to adjust for that in the next example. But for now, we'll just paste this in and then hit enter. And our calculator spits out this number, 1134.897, and so on. And we're just going to round that to 1135. And we conclude that a student getting an 1135 on the SAT will lie at the 75th percentile in the distribution. For our next question, we want to find the score bounding the top 5% of SAT scores. So this time we have a right tail containing a probability of 0.05. So again, in the calculator, we press second and then vars to get to the inverse norm distribution. And we can go ahead and put in our probability of 0.05, just remembering that that's in the right tail of the distribution. And the calculator has remembered the mean and standard deviation for us, but we still need to switch the tail to the right side. So we go ahead and paste that and we hit enter. And we get this number, 1328.97, and so on. And we'll go ahead and round that to 1329. So we conclude that the boundary for the top 5% of scores is 1329. Now I want to point out that for those of you with slightly older calculators, the TI-84 can only understand leftward areas instead of allowing you to choose the right tail. In this case, you have to compute the area to the left of the cut line by yourself. So instead of 5% being to the right of the cut line, we change that to 95% being left of the cut line. In other words, the 95th percentile. So we go to second plus variables, we go to inverse norm, and we put in that percentile, area to the left being 95%. The mean and standard deviation are the same. And again, if you have an older TI, you don't have this tail menu at all. It's going to automatically give you the left tail. And we paste that and hit enter. And we can just verify real quick that we get the exact same number as using 5% in the right tail. Now for the final type of question we can see for inverse norm, we're asked to find the scores bounding the middle 50% of the distribution. So in our TI-84, we just go to inverse norm again. And we put in 0.5 for the area, and then we put in center in the tail menu. We paste that and hit enter, and the calculator outputs an interval bounding the middle 50%. So on the left side, we've got 865.1, which we're going to round to 865. And on the right side, we've got 1134.897 and so on, and we're going to round that to 1135. So we conclude that the range of scores from 865 to 1135 captures the middle 50% of the distribution. Now, one final note for those of you with slightly older TI-84s, remember the inverse norm function only understands probabilities left of the cut line. So before we can use the inverse norm function, we have to calculate the probabilities left of each of these cut lines. So notice for this middle 50% region, if I imagine a dividing line right at the center of the distribution, I have a probability of 25% to the left of that and a probability of 25% to the right of that. Now, since the lower half of the distribution is 50%, that means the area in this left tail is 25%. So we have the area left of x1 is going to be 25%, And then we make a similar argument for x2. The area in the right half of the shaded region is 25%. So that's 25% to the right of the midline for the distribution, which puts x2 at the 75th percentile. So we head over to inverse norm again. And remember, x1 was at the 25th percentile, so I'll put in an area of 0.25. And our older model TIs are only going to be able to calculate area to the left. So to simulate that, we'll select left in the tail menu. And we'll paste that and hit enter, and we get the same number for the left boundary. That's 865, so a score of 865 on the SAT. If we go back into the inverse norm function, I can find that x value for the right boundary corresponding to an area of 0.75. And again, that's the area to the left of that cut line that we called x2. We paste that in and hit enter, and we get that same score of about 1135. In the next video, we learn how to compute confidence intervals for a single proportion in the TI-84. I'll post a link to that video at the upper left, and I'll see you there.